Hello, everybody. I know it's been quite a long break since we posted on the channel, but I am back with a new video here, and I wanted to start a calculus series because I find math to be interesting, and I know a lot of people do too, and also a lot of people like need some help with stuff, and that's great, and I want to be able to help provide that help. But we should be starting to post more regularly here. So yeah, let's just get into it. So the first thing that a lot of teachers cover in calc, especially in AP calculus, is limits. So that's what I want to start with for this channel's calculus as well. So there are many different methods to find a limit, but let's look at this limit that I've put here. So when you have a limit, we're having the limit as x approaches 1 of this expression, you can just plug in what this value is for x. But you can probably guess here that when you plug in 1 for x down here, that's going to go to 0. But in the top, it's also going to go to 0 because you'll have 1 plus 4 minus 5, and then the 1 and the 4 would go to 5, so 5 minus 5 would just be 0. So this is going to be 0 over 0. And this is one of a few of what is called indeterminate form. So we can write this here. We can say indeterminate form, and if you're taking like AP Calc or something, you do have to write this out for the test. So what does this tell us? Well, indeterminate form tells us that there should be a way to simplify it to get the limit to exist. And in this case, that's definitely true because if you look at the top of the expression here, the numerator, we see that it's x squared plus 4x minus 5. And you can actually factor that to reduce that, so let's write this here. So we'll go the limit as x goes to 1 of, so I mean it's pretty much basic factoring from algebra. So what multiplies to -5 and adds to 4? Well, that's going to be x minus 1 and x plus 5. And then this is all over x minus 1. And so you can see here that the x minus 1s, well, you can just cross them out. So you can actually solve this because when you cross those out, this would result in the limit as x approaches 1 of x plus 5. And then if you just plug in the 1, you would have 6 here. So that's a good way to do this. If you see like a factor of the numerator on or in the denominator or vice versa, that's a good way to do it. Is factoring whichever expression you can and then crossing out the like common factors. So that's a good way to do that. Now let's erase this here. So next, okay. So here I've put up another question. And this one's going to not be factoring, but here we can see, let's just show that this is in intermediate form, or intermediate, indeterminate form first, just to make sure that we really cover all our bases here, because, potentially it might not be, and in that case, we wouldn't have to do any algebraic work or something. So if we plug in 4 here, we'll have 2 minus the square root of 4 over 4 minus 4. And then we know that the square root of 4 is 2, so that would go to 2 minus 2, which is 0 over 0. And so we have indeterminate form. Okay. So now that we have this, we can employ a method, which is called like multiplying by the conjugate. And if you've done pre-calc or you've done something with rational numbers before, you've probably heard of this, or imaginary numbers, sorry. You've probably heard of this in regards to like simplifying imaginary numbers. Um, so we have, let's put this in parentheses, 2 minus the square root of x over 4 minus x. And then multiplying by the conjugate, well, what you're going to be doing is multiplying by the conjugate expression of whichever term has like the square root in it, for example. And the conjugate is like the same expression but the opposite sign. So by opposite sign, I mean you'd still have the 2, but instead of minus, you'll have plus the square root of x over, and you have to do it over 2 plus the square root of x because this would go to 1, keeping the limit the same. So you just have to make sure you do it to both the top and bottom. And so then this would go to the limit as x goes to 4 of 4 minus x, and that's just multiplying these because you have a plus b times a minus b equals a squared minus b squared. And then over, and so what we're going to do is we're not actually going to distribute for the bottom, and you'll probably see why here now, times 2 plus the square root of x. So let me extend this. So looking at this, you can see that now these cancel out, which is the main reason for doing this method, is to get the terms that go to 0 to cancel out. So we would just be left with here the limit as x goes to 4 of 1 over 2 plus the square root of x. And then plugging in 4 for x, you get 1 plus the square root of 4, which would be 1 over 2 plus the square root of 4, which is 2. So that would leave us with 1 over 4 as our answer. So that's a good example of that method. And then there's one more that once you learn how to take derivatives, which I will go over in a later video, will actually be like super useful. But I will talk about it here. So let's just say the limit as let me think about a good question here. So a good one for this would be as x approaches 0 of, say, e to the x minus 1 over x. Now, if you guys have maybe gotten into calc somewhat and using this as a refresher, you'll probably realize that this is going to be a L'Hopital's rule question, which it is. And so basically what that means is when we plug in 0 here, we'll have e to the 0 minus 1, which would be 1 minus 1, so 0. And then plugging in 0 for x down here would just go to 0. So we have the indeterminate form again. Yep, and then, so basically what it says is if you have the limit as x approaches 0 of the top expression, which you can say equals f of x or something, equals 0, right? And then you also have the limit as x approaches 0 of the bottom expression equals 0. Then you can simplify this to, and let's just say here, I'll write it here. I'll say e to the x minus 1 equals f of x, and x equals g of x. So now you can simplify this to the limit as x approaches 0 of f prime of x over g prime of x, where those are just the derivatives of both expressions. So knowing this, we can take the derivative of f of x, so we can go to f prime of x. And then if you remember the derivative rules, the derivative of a constant is 0, but the derivative of e to the x is just e to the x, which is kind of a crazy thing, and um, it has a lot of like important applications in math, but we don't have to get into that. Um, and then the derivative of x, we can say that this is x to the first. So what you have to do is take the 1 down and then subtract 1. So this would be 1 times x to the 0th, which is equal to 1. So pretty much the limit goes to the limit as x approaches 0 of e to the x over 1. And in this case, you can just plug in 0 for e to the x now. So when you plug in 0 for this would equal 1 over 1. So the limit is going to be 1, and that is our final answer for this one. Great. So those are 3 examples. And then we can talk about another thing that you'll probably see a lot. So let's say something like the limit as x approaches infinity. That's a bad infinity. Let me redo that. That's better, I guess. Of like some random polynomial expression, we can just say like 5x squared plus 2x plus 1 over another random one, like maybe 10x squared minus x plus 3. And so I bring this up because you'll find that like the rules for finding horizontal asymptotes kind of apply to like this question here. So what I mean by that is let's actually multiply both sides by, or top and bottom both, by 1 over x squared. So this would go to the limit as x approaches infinity of 5x squared. Well, we can realize that when you take 5x squared over x squared, that would just go to 5. So let me just write that instead. And then when you take 2x over x squared, that would be 2 over x. And then when you take 1 over x squared, that would be 1 over x squared. Over, same thing here, 10x squared over x squared would just be 10. And then negative x over x squared would be minus 1 over x. And then 3 over x squared would be plus 3 over x squared. So if you plug in infinity for x in these cases, well, if you have any number, like any finite number, so say like 50 or something, just any number over x, well, if the denominator is infinitely big, then this will just go to 0. And that's because at some point, the denominator is just so big that the number is just so like infinitesimally small that it's just so close to 0 that that's basically what you can regard it as. So knowing this, and since x squared is even bigger than x, if that goes to infinity, 1 over x squared would also go to 0. So knowing that, we can say that this equals 5 plus 0 plus 0 over 10 minus 0 plus 0, which equals 5 over 10, which would equal 1/2. And this brings in the asymptote rules, because if you realize, asymptote rules say like if the highest powered term in the expression, like if they're the same, which in this case they are, the highest terms for both of these is x squared, then you just divide the leading coefficients of the polynomials, right? So in this case, you can just say 5 over 10, which equals 1/2. And so it's the same answer, and that's kind of like where horizontal asymptotes come from. And then the other rules also work the same way. So like say we got rid of this, right? Um the denominator's exponent is bigger, so if you think about it, that would grow faster. And you know the horizontal asymptote rules say that that would go to 0 as the horizontal asymptote. So if you got rid of that, then that's what it would go to. It would indeed go to 0. Um, and then if you have something else where it's like the opposite, so let's say like x cubed over x, um, like plus 1 or something, then you can say that the top will grow faster than the bottom, um, or you can just think back to like the asymptote rules and think when the when it was infinity, or when the top was higher, um, I believe there was no horizontal asymptote. So this will go to infinity. Um, and yeah, so that's just something that's interesting. So that's some pretty basic stuff about limits here. In the next video, I might be doing an SAT video actually, but in the next calculus video, I hope to get into some derivative rules and basics. But that's all I have for you guys today. Thank you for watching.